Welcome, first graders, to the Dallas Independent School District's STEM Environmental Education Center. I'd like to give a special welcome to the students at the Virtual Academy of Dallas ISD, Ignacio Zaragoza Elementary, and Lee McShann Elementary. Thank you so much for joining us this morning. We wish you could be here in person for an in-person field trip, but since you can't be here today, we're going to do our best to make you feel like you're here during a virtual field trip experience. This morning, or if you are watching this and have not registered for this field trip yet, you can still do that by going to www.tiny.cc/pk-2 registration. Once you get there, you can get yourself or your class registered for this field trip. We just use that information for our attendance purposes. And this morning's field trip is going to be all about the weather. During this virtual field trip, students will observe weather conditions, including relative temperatures such as hot or cold, clear or cloudy, calm or windy, and rainy or icy. So we're going to start things off this morning by exploring temperature with Mr. Ramirez. Next, we're going to learn about different types of clouds with Mr. Monroe. Third, we're going to explore different types of precipitation with Mr. Dominguez. And last but not least, we're going to learn about wind conditions with Ms. Schramm. While we're doing all of that, you can ask us questions. Since this is a virtual field trip, the way you ask a question is you'll go to www.tiny.cc/question-answer to fill out a super short form to submit any questions you have related to the weather to us. You can ask as many questions as you like, and we will do our best to answer all of them in the time that we have with you this morning. So let me stop sharing my screen here and turn things over to Mr. Ramirez, who's going to get us started with temperature.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about weather, specifically the temperature. So today, we're going to be a special scientist called a meteorologist. A meteorologist is simply a scientist that studies the weather. And in particular, again, today, we're going to be learning about temperature. Temperature tells us how hot or cold it is outside, and we use a special science tool called a thermometer. So a thermometer is a science tool that tells us the temperature or how hot or cold it is outside. You guys are probably familiar with a thermometer. Here's an example of what one looks like. This thermometer has been sitting in my room, and if I read it, it tells me that my room is about 70 degrees Fahrenheit. The way a thermometer works, super simple. There's usually a liquid inside the thermometer. It's usually red, as you can see here. When that liquid gets hot, the liquid will start to rise or move to the top. So the top upper numbers are going to be your warmer temperatures. And when it's cold outside, that liquid will start to shrink. It will move down the thermometer. So the bottom numbers are usually the cooler temperatures. So to demonstrate how a thermometer works, I actually have another science tool called a hand boiler. It has a liquid inside very similar to the liquid inside our thermometer. When the liquid gets hot, the liquid will move to the top. And when the liquid cools down, it will move to the bottom. Now, I'm actually going to use my body heat to warm the liquid up to see if we can make it move. My hands are not that warm right now. What is something that I can do to warm my hands to make this liquid rise faster? You guys can show me. What do you think I can do to make my hands warmer? Hopefully you guys are doing it. I have a hard time keeping my body warm, so something I can do to keep my hands nice and warm is to rub my hands super fast together. So rub your hands really quick, super fast, just like this. I am generating heat by friction. Friction is rubbing things together. So I am rubbing my hands together, making my hands nice and warm. So hopefully my hands are just a little bit warmer. You can see that that liquid is starting to rise to the top. So when a thermometer gets nice and warm, the liquid inside will rise to the top. And that's why when it's hot outside, especially during the summertime, the liquid is more at the top of the thermometer in the higher numbers. During the wintertime, when it's cooler, the liquid will shrink or go back down the thermometer toward the bottom numbers. So when it's hot, the liquid rises. When it's cooler, the liquid will fall down. So that demonstrates how our thermometer works. Now, the next thing I want to talk to you guys about is why it's important to even be learning about the temperature. The temperature affects us and it affects the animals that we have. So I actually have an animal friend that I want to introduce you guys to. His name is Spike, and he's a reptile. You've probably met him before. Spike here is a bearded dragon lizard. So we know that he gets that name because he has a beard of skin underneath his chin. When he gets scared or mad, he can inflate that beard to make himself look really big and scary. Now, temperature is super important to Spike because when it's cold outside, Spike does not like it. Spike has to have a very special temperature between 90 to 100 degrees. He likes it very warm to help him stay alive and survive. You usually will not see reptile friends very active during the cold winters. So I'm going to go ahead and put Spike, our reptile friend, up. He's rather fidgety right now. And we're going to look at some examples of temperature and how it affects the animals and plants here at the Environmental Center. So teachers, feel free to pause the video really quick if you would like. Students, see if you guys can find which tool is used to read the temperature. Also, feel free to discuss what do you think the weather is like on this day. So I have a variety of science tools behind my classroom. All of these are great weather tools. So again, see if you can identify some of these weather tools and also see if you can find the tool that is used to read the temperature. Feel free to pause the video, but for time, I'm going to go ahead and move right along. So hopefully you guys said the thermometer. So a thermometer is that special science tool that is used to read the temperature. And if we read this thermometer, it tells us that it is about 44 degrees Fahrenheit. That is rather cold to me. And this was taken last week on Thursday. Here's another example of a thermometer. On this day, the thermometer read 40 degrees Fahrenheit. So it was another cold day. And then here's our work cat WC. Think about, how does temperature affect our animals and how does this affect you? So WC is a mammal. Mammals have hair or fur. So take a moment, touch your head. Do you guys feel hair? You guys are also mammals too, just like our WC, the cat. So think about, how does temperature affect animals and even you? Luckily, WC the cat has fur all over his body, and that is what keeps him nice and warm during the winter time. So think about, what do you do when it's cold outside? Hopefully you guys put on some coats and jackets. So if you guys saw that thermometer reading was taken on Friday. Notice it is 26 degrees Fahrenheit. That is very cold. That is actually below freezing. So this line right here on the thermometer, that is the freezing point. When it gets below that line, water can actually freeze. So Friday was actually a very, very cold day. It was so cold that the water in our pond actually froze. So this is our little duck pond. Notice the leaves and the sticks and the acorns froze inside the water. We have a big, thick layer of ice. Now, hopefully, once the temperatures rise and get warmer throughout the day, that water will eventually melt. And that was our duck pond. So look at our poor little ducks. Their pond froze. Here's some of our farm animals. How does the temperature affect the farm animals? What do you think those piggies want? I think they want some water. But what happened to their water? It froze. So again, it was very cold that morning. The top layer of their water actually froze and was a solid piece of ice. So the animals didn't have any water. So we had to go out there and we had to break the ice with a stick. So you can see the water froze. It turned to a hard solid. It's like when you guys put water in the freezer, it turns solid into a chunk of ice for you guys to make ice cubes. And you can hear them slurping up that water. Again, when it's 32 degrees Fahrenheit or below, water can freeze. It turns from a liquid to a solid. And hopefully when it's that cold outside, you guys are wearing coats and jackets, maybe some gloves and scarves to help your body stay warm. You can see there's our chunk of ice. That was a big chunk of ice. Now, because this is January and we're in the season of winter, most of the temperature readings that I took this week were all on the colder side. But when it starts to warm up in the spring and summer, the temperature will start to get warmer. So that's all I have for you guys today on temperature. We're going to give it back to Mr. Broughton to answer any questions.
Thank you, Mr. Ramirez. The question that came in was, what is the temperature where we're at right now? And I think you can maybe see this on the screen here. Just 37 degrees here, but it looks like it's going to get up to 55 degrees this afternoon. And we've got some warmer days coming ahead too. So a little bit chilly this morning, but it's going to warm up today and tomorrow. All right, now we're going to learn about different types of clouds with Mr. Monroe.
Good morning, students. My name is Mr. Monroe, and we're going to be investigating or looking into the different clouds that we see in the sky. There are a lot of different types of clouds. In fact, I'll tell you this, when I was your age, I would look into the sky and I would see this white puffy formation in the sky. And the first thought that would come to my mind is, there must be a fire somewhere. That smoke coming from a fire. Well, I was very wrong because they were actually clouds. Now, I'm going to do a short presentation with you guys, but before I get started on that presentation, there's a little lab that I'm going to do with you that kind of explains how clouds are formed. So bear with me, I want you to watch, because if you were here person to person, I would have you looking at what I'm doing very closely. So hopefully you'll be able to see what happens. I'm going to take this canning jar, it's a pint size, and I'm going to cram it full of ice. Putting some ice in it. And I'm going to really cram it full. Oh boy, I have packed it in there very tight. And now I'm going to wipe the outside of it to make sure that it is completely dry. Now, if you were here person to person, or we were doing person to person today, and you were right here, I would have one of you all come feel the outside of this jar to make sure that it was dry. Now, I will tell you what you would feel is that you would feel the coldness of the ice. The next thing I'm going to do, I would have one of the students come witness to make sure I didn't cheat. I'm going to pour water from this flask right down the middle of this jar. Not on the sides, but down the middle. And I can see, and maybe you can see, that the ice is beginning to melt. I'm going to pour just a little more. And I'm going to set it right here. I'm not going to bother it anymore until I finish this short presentation. So if you bear with me for just a moment, I'm going to share my screen with you guys, and we'll get started with the presentation. And that's my assistant back there trying to tell me I'd better do this right, okay? That's old Smokey the rooster. He gets excited when he hears human voices. Well, today's subject is clouds. Now, we're going to be going over how clouds are formed. Okay, you're going to learn about that. And then we're going to be discussing the different types of clouds. Now, clouds form when water vapor in the air becomes a liquid, water or ice crystal. And the thing about water is that, you know, water is one substance that can be found on the planet Earth in the three natural forms of matter. It can be a liquid, it can be a gas, and it can be a solid. Those are the three natural forms of matter. Now, listen, guys. Meteorologists, and you heard Ms. Ramirez talk about those very special scientists that study weather. Meteorologists call all the air that surrounds our planet the atmosphere. Now, they have another name for it that really kind of describes it. They often refer to it as the air bubble that surrounds our planet, and it can go up quite a ways above us. Now, in the atmosphere, you can find the three natural forms of water, or the three natural forms of matter concerning water. You can find it as a liquid, you can find it in the atmosphere as a solid, and you can find it in our atmosphere as a gas. Now, the gas form of water is called water vapor. And I've explained that to many a student by using my aquarium back of the room here. The water level constantly goes down, and I know that the animal that lives in that aquarium, that snapping turtle, he's not drinking all that water. It is going through the natural process of changing from a liquid into a gas. And I explained to the students that right now, water vapor is all around us, okay? It's invisible, so we can't see it. So let's go ahead and learn about clouds, and we'll come back to the little experiment, and I'll talk a little more about that process that we call condensation. You know, condensation actually happens in the atmosphere. When the water vapor reaches the high, cool air, it turns into water droplets that form clouds. So right there, that tells us what are clouds made out of. They are made out of water. This is condensation and is part of what we call the water cycle. There are several components or factors that make up the water cycle. Evaporation, that's the changing of the liquid into the gas. And then once it cools off, it changes back from the gas into the liquid. We call that condensation. And then later on, you'll learn about precipitation. That is when the clouds get so saturated, they release that water and it falls back to the earth in the form of some type of precipitation. Types of clouds. Now, there are a lot of different types of clouds, students, but I'm only going to be focusing on maybe 4 types or 5 types. And the types of clouds that I'm going to be referring to, or we're going to be learning about this morning, are clouds that even meteorologists will tell you they are clouds. These type of clouds are clouds that can help you figure out what the weather is like right now, or what the weather might be like in a day or two. So let's get started. You know, there are many types of clouds, just like I said. Clouds are classified simply by their color, their shape and size, where they form in the atmosphere. And we're going to start out by looking at these clouds in this image. Now, these clouds are covering up the entire sky. And you will see light and dark images that make up this cloud formation. In some places it's lighter, some places it's darker. So this type of cloud formation is referred to as a stratus cloud, usually covering up the whole sky, but not really dark or not solidly dark gray. It'll have a few light spots in it. And usually stratus clouds are not very high up in the sky, okay? These clouds have sheets or layers, and these clouds they bring light snow or rain or drizzle. Then we have what we call gravity pulling on the clouds. Now we know that gravity pulls everything down toward the ground, right? It's actually holding us in place. Well, it also pulls sometimes clouds down to the ground. When they come down to the ground, it creates a phenomena that we call, or a condition that we call fog. Now, a cloud in contact with the ground usually is called fog, and it's a type of stratus cloud, as we see in this image. Now, not too long ago, got up in the morning, and especially when I was trying to come to work, we had fog, and it made visibility very poor, meaning as I was driving, I had to drive very slow and cautious because I couldn't really see a great distance in front of me, like on a normal day. Now, we also have what we call NIMBOSTRATUS clouds. Now, these clouds are a little bit thicker, but they still blanket the sky and they completely blank out the sun. They cause steady rain or snow, meaning probably going to have some heavy rain that is going to be steady. It's not going to be in rain showers here and there. It's going to be heavy rain, steady rain. And if the air temperature is just right, below freezing, we're going to get pretty good snow. And then we have what we call cumulus clouds. And these are my favorite clouds. These cumulus clouds are pretty clouds. White and puffy clouds that usually mean good weather. So there is a cloud type that indicates what kind of weather we are having. Cumulus clouds could look like these in the images that you see here, and they are really fun to watch. Sometimes you can use your imagination. People often see pictures in the sky made by cumulus clouds. And then we have cumulonimbus clouds. Wow. These usually indicate something is going to happen. These are dark towering clouds that are also called thunderheads. These clouds produce heavy rain, thunder, and lightning, and can produce vortexes that we refer to as tornadoes. This is really a storm type cloud. They look like this. Now, they say that the higher the thunderhead or higher the towering cloud is, that indicates that there are very strong winds that are up in the upper part of that cloud. These are very dangerous possibility clouds. I call them danger possibility because of what's associated with them, especially lightning. Here in North Texas, we do have, when we have these type of clouds and these type of storms, a lot of lightning strikes, which can create fire. And here's a variety of images that show cumulonimbus clouds. Often referred to as nimbus. And then the other group or other type of cloud are these high whispery clouds that we refer to as cirrus clouds. Cirrus, they never laugh at a joke. No, I'm just kidding, guys. Cirrus clouds basically are feather-like, thin feather-like clouds that are made up of ice crystals that are very high in the atmosphere. Most of the time, they're above 20,000 feet above the surface of our planet. And this usually means a change in the weather is coming. Here's a variety of images that show cirrus clouds. Sometimes cirrus clouds are referred to as mare's tails. Cirrus clouds in this image here is actually showing a stratus cloud down below here rolling in. Wow, isn't that something? What does the color of a cloud tell you? Well, that can tell you things too. The color of a cloud lets you know how much water it contains. White clouds have very little water. Dark clouds usually mean heavy rain, okay? Gray clouds can mean snow or rain. So you see, colors of clouds can mean something. Where do clouds form? Later on, as you get into the upper grades, you're going to learn about weather fronts. Clouds usually form along weather fronts. Now, I'm going to stop sharing my screen with you guys. And we're going to come back to that jar of water. It is now melted, and I can see that around, you can see it's kind of foggy around the edge of this jar. Well, I'm going to take a Kleenex. Is now wet. So how did the water get on the outside of the glass to make the outside wet? Well, condensation. The same way that clouds form in the atmosphere. Remember, The changing of the gas back into the liquid form is called condensation. That's exactly what happened here. The air around this jar, it got cooled off. There was invisible water vapor in the air that was around here. When it cooled off, it had to have something to attach to, so it attached itself to the outside of the glass, okay? It's just like you putting a soda can in the freezer and then don't let it stand there long, but when you take it out, it's going to be wet on the outside after you set it on the table. That is a form of condensation. That's the same way that clouds form. All right, you guys have a good day, and I'm going to turn it back over to Mr. Broughton. So if any of you have any questions, I bet he can answer them for you.
Thank you, Mr. Monroe. The question that came in was how many different types of clouds are there? And it depends on what source you use. I'm going to just share one real quick. This is from the National Weather Service, and you can see, according to this poster, there are quite a few different types of clouds. But again, those four that Mr. Monroe shared with you also are considered the four main types of clouds. So it just depends on where you look. All right, I'm going to stop sharing my screen here and turn things over to Mr. Dominguez, who's going to explore different forms of precipitation.
Hola amigos, en este paseo virtual vamos a hablar de la precipitación. Primero vamos a responder a la pregunta, ¿qué es la precipitación? Y luego me van a poder dar dos ejemplos de precipitación. Aquí en este video miran un poquito de lluvia, ¿verdad? Tuvimos un poquito de lluvia este fin de semana, ¿verdad? La lluvia es una forma de precipitación. Pienso que en este momento me pueden dar o pueden adivinar qué es la precipitación y a lo mejor otros ejemplos de otros tipos de precipitación. Si la lluvia es una forma de precipitación, ¿cuáles otras formas hay de precipitación? All right, guys, so in this virtual field trip, we will be talking about precipitation. We are going to answer the question, what is precipitation? And then after we answer that question, you guys will be able to give me 2 examples of precipitation. Now, in this video, you see rain. And I'll tell you what, rain is a type of precipitation. I bet that you may be able to guess what precipitation is and maybe even give me a couple more examples of other types of precipitation. We had a little bit of rain this weekend. We definitely needed the rain because a lot of living things, well, all living things depend on rain. Now, it's winter, and unfortunately, one of my favorite types of precipitation is not always available to us here in Texas. What other form of precipitation do you guys think Mr. Dominguez really wishes he had during the winter time here in Texas? Well, we're going to find out soon. I hope you guys enjoyed this virtual field trip. Let's get started. So I have a question for you guys. When you look up towards the sky, what do you sometimes see? You see clouds. And what are clouds made of? A lot of people don't know this, but clouds are made of water. And when that water falls back to the ground, it is called precipitation. And that precipitation takes different forms depending on temperature. Okay, amigos, tengo una pregunta. Cuando miran hacia el cielo, ¿qué miran? A veces miramos nubes, ¿verdad? Y esas nubes están hechas de agua. Cuando esa agua cae hacia la tierra, se dice que es precipitación. Y precipitación viene en diferentes formas que depende en la temperatura. Ahora quiero explorar algunas diferentes formas de precipitación. Vamos a comenzar. Primero quiero empezar con una de mis favoritas formas de precipitación, la nieve. La nieve se forma cuando las temperaturas son bajo cero. So guys, one of my favorite forms of precipitation is snow. And in order for snow to form, temperatures have to be freezing or below 0. Now, I know that we don't get a lot of snow here in Texas, but we definitely got plenty of it last year, did we not? So let's hope that we get some snow this year, but not too much where we miss school. Do you guys agree with me? Una de las formas más violentas de precipitación es el granizo. El granizo cae en forma de hielo, bolas grandes de hielo, y pueden dañar los carros, pueden dañar las casas y también lastimar a los animales y también a ustedes. Tenemos que tener mucho cuidado cuando la precipitación es granizo. So guys, another form, a very violent form of precipitation is hail. And hail can damage roofs, it could damage homes, cars, and can even hurt you and other animals. So hail is a type of precipitation that falls down from our atmosphere in the form of ice balls. Sometimes they can get very big, baseball-sized even. Ya hemos mencionado que la lluvia es una forma de precipitación, pero aquí podemos ver diferentes tormentas dejando caer toda esa agua de nuestra atmósfera. Although we've already mentioned that rain is a form of precipitation, here's another look at different storms letting all that water fall down from our atmosphere. So this is a wonderful look at different storms creating different types of precipitation, mainly rain. Otra forma de precipitación es la agua-nieve. La agua-nieve son bolitas pequeñas de hielo que a veces también son mezcladas con lluvia y nieve. Another form of precipitation is sleet. Sleet are small balls of ice that sometimes come mixed with snow and rain. Let us not confuse sleet with hail. Hail is larger, sleet is smaller balls of ice. All right, guys, now that we've learned a little bit about precipitation and can name a couple of examples of precipitation, I had a very important question before I let you guys go. Why is precipitation so important? ¿Por qué es la precipitación importante? So, let's think about it. Imagine a world without precipitation, without rain, without snow. Do you guys think that all that water that gathered in our atmosphere, if it stayed up there and it never fell back down, do you guys think that these animals could survive? Take a look at these ducks. They definitely enjoy their water. Would they be able to survive without precipitation? I don't think so. Have a discussion with your classmates about the importance of precipitation and how it affects your lives. Have a great day. I hope to see you guys next time.
Thank you, Mr. Dominguez. The question that came in was, what is your favorite form of precipitation? And it would probably be a tie for me between rain and snow. Sleet is just cold and wet, and you really can't do anything out in that. And then hail could cause a lot of damage. So I would prefer rain or snow. All right, now we're going to explore wind conditions with Ms. Schramm.
Good morning, everybody. We are talking all about wind. And let me get my screen going. Perfect. Okay, so at the end of my little section, you'll be able to demonstrate that air is all around us and that wind is moving air. So that first part, that air is all around us. We can prove this So if you put your hand and wave it back and forth, you can feel the air pressing against the back and the front of your hand. So kind of wave it in front of you or fan your face. You can feel that moving air on your face. Okay, so my other example is this little puppy with his little head out the window. So he is feeling the air as the car is moving forward. It's moving through the air and he is hitting the air with his face. So his hair looks like it's blowing in the wind, but really it's the car that's moving through the air. So both when you fan yourself or if you've ever stuck your hand out of the window and kind of felt the waves of air, that is proof that air is all around us. So windy or calm. The first tool that we can use to see if it's windy or calm outside is just by looking at the trees. So you can see the tree on the left is a palm tree and all the fronds are spread out evenly. It's exactly how it's supposed to look. You know, the air is calm, it's not moving. Then in the picture on the right, it looks like there's a strong breeze and wind. So it looks like a windy day. All the fronds are pushed to one side. Just like when you're out in the wind, your hair gets pushed out to one side. So you can tell by looking at the trees that it's windy or calm. All right, so some other tools, we're gonna go over some different tools that we can use to tell the weather about the wind, but also that students can make themselves. So here are some wind socks, and the one on the bottom, that's more for like meteorologists to use because it's a big kind of official wind sock. It looks like the Cat in the Hat's hat. And basically how that works is the air fills up the tube. So it's like a tube, like a sock, and it floats in the wind. So if it's not windy, it's just going to floop, flop. And if it is windy, it's going to look like it's standing straight out because it's filled with the moving air. So you can make those out of just cardboard, construction paper, and ribbons, like you could see on the top. Those are made by students. Of course, you don't want to leave them out in a rainy day, but for a windy day, you can see them and they'll blow all those pretty colors around, just like that picture of the store-bought one on the left. So that is a wind sock. And wind chimes. So sometimes these weather tools or indicators of wind are used for decorations or like for your garden. So you can make wind chimes out of recycled materials, sticks, beads that you're no longer using. The one in the middle has a terracotta pot. And then the one on the right has all these tin soup cans. So after they were done with their soup, this person saved their soup cans, washed them out, painted them, and recycled them into something beautiful again. So the fun thing about wind chimes is depending on what materials you use, you can make different sounds. So I have a few wind chimes in the pollinator garden out here at the environmental center that I brought inside. So of course it's not going to be windy inside because the air is still, right? We're not outside, the air is not moving, we don't have wind. So I just got to shake it up a little bit. So this one is made of like little kind of shells. So that makes a pretty kind of softer noise. And then I have another one that's made out of metal, and it's kind of, they sound like something you would have in your music class. This one is much louder. I love this one because even when I'm in my classroom on a windy day, I can hear that it's windy. I don't even have to look. I can just hear it. So I like the sounds this one makes too. As you can imagine, those tin cans would make a different sound and the beads as well. So those are pretty fun. Okay. Okay, this is, whoops, okay. The weather vane. So you may have seen these out if you've ever been on a farm or a ranch. You may have seen a weather vane before. On the far right, there's a horse on top, and it's got an arrow that looks like the horse is running on. And then it's got those letters. Sometimes you might see them with a rooster on top. And then those 4 letters. So it's an NSEW. That stands for north, south, east, and west. Those are our cardinal directions. So the weather vane points to which way the wind is blowing, right? And that's useful because you want to know which way the wind is coming from. So if there's a storm out west and the wind is blowing from that direction, you want to know, so you can look to the west and see, oh, a storm's coming in. So that can be a helpful tool to know which way the air is moving. And then there's some student examples of a weather vane using some, once again, recycled materials to show you which direction the wind is blowing. And then this one, the anemometer, I always mess up how to say this one. It gives me like a tongue twister. But this one can tell us how fast the wind is blowing. So the student example doesn't really have a gauge to tell us how fast the wind is moving, but the professional ones do. So you can see these ones kind of look like little cups or little bowls. And when the air fills up those little bowls, it pushes them and turns it around and around and around. So they look kind of like big spinners. And you can see on this one, the meter is right there. So it's telling them how fast the air is moving. And usually the way we measure how fast the air is moving is with miles per hour. So if the wind was moving for an hour, how many miles would it travel, right? So miles per hour. And we can use the Beaufort scale to tell us about different levels of wind and what that actually means. So I'm just going to go over a few because I know this is a big, crazy chart for first grade friends. So a level 0, if you were to have a campfire, the smoke from the fire would just go straight up in the air. The air is not blowing. There's 0 miles per hour movement. It's very calm. Then towards the middle, like a level 6, if you looked at the trees, large branches would be swaying, like that palm tree where we saw all the fronds on one side. You would see a lot of movement in the air. And that would be a strong breeze from like 25 to 31 miles per hour. And then one that's way more intense at the end of the scale at a Beaufort 12, you would see extreme damage like tornadoes, hurricanes, really, really, really strong winds that would do damage to buildings. So there's kind of the quick overview of the Beaufort scale to compare different wind speeds. All right, then we got windmills. We have little pinwheels, which are super fun. And I have some of those in my garden out here. And basically the moving air, the wind hits those kind of paddles and pushes them and turns them around. Once again, like another spinner, but this way it's standing up. And you may have seen, if you've traveled and driven through the country before, you probably have seen those giant new windmills. They look like giant fans. And those not only are spinning around, but they're turning that wind energy into electricity. So those are kind of the more modern version of what's on the bottom, which are the old-fashioned windmills. So you might see either kind while you're traveling. And let's see, whoop. And there's kind of a little student example. And once again, that one's not making electricity, but it's there for decoration. Okay, so let me see. Okay, my last thing is flying a kite. So this invention is not really a tool, it's more of a toy, but it's fun to use on a windy day. So you have to have the right conditions to make a kite fly. You have to be in a cleared out area. So a lot of times you see people doing them using them at the beach or in a field where there's not trees, because as you can imagine, a kite could get tangled up in branches. But kites are really fun. They come in all different shapes and sizes, and they use wind energy to fly. So just like how the wind and the moving air was pushing against all those other items and tools we had, this kind of pushes against the kite and lifts it up. That's why you need a windy day for a kite to work. So that's all I have for you today. I hope you have a great rest of your day, and I can't wait to see you next time.
Thank you, Ms. Schramm. The question that came in is, what is another way I can find out the wind speed? You can use that same app that I showed earlier. And if you look there, it shows the wind is blowing at 1 mile an hour today, which is not very much. And then you can also go outside and pick up some grass. If you ever watch golf, which you probably don't, but if you do or ever play golf, you might see a golfer picking up some grass and dropping it, because that will kind of give you an idea of how fast the wind is blowing and what direction. And I like this picture too, because you can tell by the clothes that this person is wearing that it is a cold day for golf. All right, let's do a quick recap of what we did this morning. Again, this virtual field trip was all about the weather. During this virtual field trip, students observed weather conditions, including relative temperatures such as hot or cold, clear or cloudy, calm or windy, and rainy or icy. So we explored temperature with Mr. Ramirez, different types of clouds with Mr. Monroe, different types of precipitation with Mr. Dominguez, and wind conditions with Ms. Schramm. Thank you so much for joining us this morning. We appreciate you taking the time to learn about weather conditions with us. We hope you enjoyed this virtual field trip, and you can let us know whether you did or not by going to www.tiny.cc/pk-2 feedback and filling out a short feedback form for us. We hope to see you again during our next virtual field trip for first graders. Have a great rest of your day. We'll see you next time. Goodbye.